Hello and welcome to this live GameDev Hangout. We're going to work on the open source Nexus prototype under Open or Outward Light Studio. The code is available on github.com under Outward Light Studio /Nexus. We have a current iteration that we're working on, and I've completed a couple of tasks in the previous live stream. Added controller support and was able to add rotation support to the moving hazard. I should probably create a summary video of that task. It was a bit arduous, but it boiled down to two things. First, I'm using a large language model to help me develop this game. I don't have a lot of experience with Godot and game development, so I'm heavily relying on these large language models while trying to balance my learning process. Of course, I need to learn and understand how the code works and how the generated output, whether it's going to behave as we expect. That way we can maintain the code. The other part is I didn't understand how the Godot tweens and transformations work. So what I was trying to do was transform the rotation and position independently and in parallel, so at the same time. And I didn't realize that those were all those, and there's one other property called scale, that are all three part of a transform class. And the Godot tween engine will sort of only act on the last property that you transform or interpolate of an object or class. So when I tried to interpolate in parallel the scale, the position and rotation, only one or the other was happening because I did not realize that they were part of a shared class. So what I had to end up doing in the code is in creating a new transformation and interpolating the values and sending that to the tween. Let's take a quick look at this, because it was quite challenging. And so what it boiled down to was I didn't quite understand how the transformations worked, and I wasn't feeding the large language model the right question. I wasn't asking the right question. I was asking it how to, interpolate these two properties in parallel, or tween these two properties in parallel. And it was giving me lots of answers, and very sophisticated answers, even getting down into like quaternions and things like that, which at some point seemed to indicate I was kind of on the wrong path. The more complex or convoluted the solution is, usually there's much simpler answer in a different local maxima. I was probably in the wrong solution space, or asking the question wrong, in other words. So I stepped back and I said, okay, let's look. And I looked at the screen here on the Node 3D, and it has this, position, rotation, and scale, these three properties that I was trying to tween independently or in parallel. And I realized, they're part of something bigger. They're part of a transform. So with that insight, I was able to have a quick session with Claude. Again, I'm not expert on Godot or game development, and I rely on these large language models to have embedded knowledge about even Godot 4.3 APIs and inner workings. I think they're valuable tools, but we have to be careful how we use them, and I'm learning by making mistakes. Okay, so here's the solution, just for summary. So we have this animatable body 3D, and I'm sort of working on another feature to make it visible in the user interface. But the goal is you start it, it's a Node 3D, and you start it in a single position in the map, and tell it a transformation to take over a period of time. And we started out with just a transformation here. So this is our desired transformation, I should call it, to make it more clear. Or one. So let me reset that so it's not quite so skewed. But let's say I wanted to move up and rotate at the same time. So now we have essentially a moving hazard, which I can actually land on. And it has these two transformations happening, or well, it's essentially one transformation, two properties are tweening in parallel. And it's actually one transformation that's tweening that Godot is managing in the background. All right, it was a very frustrating session because I just was in the wrong local solution space. I had to step back and say, okay, there's a place I can fly to. There's a solution I can fly to, over here that might have a better outcome. So I did that. I said, okay, let's look at this transform property. So small improvements I can make, add better labeling here that sort of mirrors the labeling. I can create a group, a UI group. I'm still learning Godot nomenclature, but I can create a group here that says desired transform, and then position, rotation, scale, desired position, rotation, scale, stuff like that. So we don't shadow these internal properties. I'll add those later. Let's take a quick look at the code, and then we'll move on to our task for today, which I suppose I might as well do that at the outset, just make those small UI improvements. Let me get on a branch real quick, and then we'll look at the code. So here's the actual pull request. It's pull request number 23. If you do want to see the final solution, and I'll actually walk through this pull request. So previously we had only one property that was animating. It was the position, and you could fly up and down or left and right or even towards the camera in a way. Even though we're a 2.5D game, we can only move in 2 dimensions. We're using 3D space and 3D assets to give it a kind of a nice aesthetic and potentially pivot into 3D at some point. We're not sure exactly, but all these things like the particles in 3D and the level and the shadows and lighting moving in 3D space, I think gives it a nice touch in the model of the rocket. So that's our aesthetic. We're going with low poly 2.5D game. So the pull request, it involved me actually setting these positions in our level, which I've only done in level 3 here. But here's the main changes. Initially, we only had a destination, vector 3, and a duration. And the destination was vector 3 of the coordinates that you wanted it to move to. And so it was essentially the position. We were only allowing the position to be animated over time. So it was like a kind of like Mario Brothers, the platforms that can go up and down, and some of them can go left and right. All right, so we were like, okay, well, we also want to rotate it and scale it. So let's expose those 3 and add some doc strings. So this is nice. When we hover over that, now we've got a little bit of information there describing the intended use. We're trying to learn about user experience in the Godot editor, how to improve that. And the desired duration is also here. And this is an experiment I'm working on, debug path. So when I set these properties, I would like to see where it will end up. And so I'm trying to find a way with Claude to have a user interface widget that will show us the end result, so I can, or even the tweened result, so I can tweak it and really get accurate level design. That's a work in progress. It's not probably going to happen. I'm going to work on something else. So we have an internal state to keep the initial transform. It's essentially where you place that in the level in the editor right now. And here is the bulk of the change, a little bit of cleanup. This was the key insight. I had to create a new transform. I couldn't work on these individual position, rotation, and scale properties independently, no matter how hard I tried with using parallel tweens and then chaining tweens, of course, so that we have going up and then coming back down. So we just create a basic transform, and we apply each of these configurations. So we translate it to the desired position, then we rotate it on all 3 of the axes, degrees to radians, because I think it's more natural to express this in degrees for like people, and that's, I think, likewise what Godot is using here. Now they're also clamping it, which we may want to do, but it could be that I want to have this thing spin like a lot. I don't know why, but if I clamp it, it can only spin once, but maybe we want to have something weird, like, see what happens there actually, if it even works. No, it won't work. Okay, so we should clamp it. I thought that somehow it could go through multiple rotations. again, all this is new to me and just learning as I go. So that would be a user experience improvement. We can clamp it here to natural values, and then the scale also, it probably doesn't need to be clamped, but that could get extreme. All right, so we have these, each of the axes gets rotated independently on the target transform. And lastly, we scale it. Okay, then we set up our tween that it loops. And we want it to be a kind of a smooth, this is a previous code, we want it to be kind of a smooth on the edges. So it's like a sine wave pattern where it'll slow down as it gets to the minimum and maximum. And smoothly transition back and not be like this abrupt some kind of movement. So here's the key. Now instead of operating on the position, which was part of, like subpart of the transformation, we're going to operate on the whole transform itself. Like taking the initial transform and multiplying it. So I guess it's using some like dot product or something internally. I'm not good at math, and that's why I was like very confused and also a bit skeptical when the solution started getting into really mathematical territory. It's not that math is bad, and math is a really important part of game development. So I'm also working in parallel to brush up on my math skills as it relates to game development. But it was just a sign I was getting in a really complex solution where there was probably something easier. And it turned out, yeah, this was like much easier solution. Then we chain the tween to go back. So this is just applying the reverse, going back to the initial transform over the period. So this duration in seconds is how long it should tween, how fast it should go. That's the whole solution. Pull request is merged. Close the issue there. So yeah, let's go ahead and move to the next task. So what we'll do is I'll create a new branch here for the moving hazard. And essentially, I think these are small enough in scope that I can use Copilot. I can open the scene here. Yeah, so it's using GPT-4. Let's try Claude preview. Aha, so we've got export group desired transform. We'll accept that, but I think it did it in the wrong order. So if we put that there, so it's decorator. And I highlighted the wrong code, so that was my fault. It should actually be here. So how does this work? Only the, let's see if this works. So you just put an empty export group. Okay, let's try it out. I think I would do that just for visual clarity. And then if I reload this in the Godot Editor, let's see what happens in the user interface. Desired transform there, and desired duration is above that. Transform duration. Well, so these are clamped from negative 360 to positive 360, just to follow the user interface. Okay, that should work. Let's try it out. It's a range, but range annotation requires a variable type float, array float with vectors. So I think it's gonna have to split those out. To fix this error, we need to split the rotation vector to accept. Let's see what it looks like. Okay, shoot, that's gonna break the script. Let's see what if it'll load in the UI. Now I wonder how they've done this. I see something. I messed that up. Okay, so we lost that variable. Gotta be careful. Yeah, LLM coding can be dangerous. Yeah, see, it's a different. Okay, well, this is interesting. Let's see if I can turn to Claude for this. Okay, so I'd like so we're starting a conversation with Claude. We went on a single row under the rotation heading. I understand you want to create a vector 3 property that appears in the inspector with 3 rotation sliders similar to Godot's built-in rotation property. Here's how you can achieve that. Export var desired rotation vector 3 0 y 360. Export range. Interesting. If you want to clamp the values, use this syntax instead. Oh, interesting. I can try this, but I don't know if it'll split it out. Let's try it one more time. We think we already tried that. Okay. Let's see. Okay. Desired transformation, export range. full context, you're replacing transform-like structure with position, rotation, and scale. Here's how to format it to match the inspector vector 3, and I don't want the default values, so we will just 0 it. Let's try the suggestion. Yeah, export range. So let's sweep these. There's still a problem. Vector 3 is 0. Yeah, and this is the same problem we had with the Copilot. The built-in UI for vector 3 will automatically provide the sliders. It doesn't. It doesn't clamp the values. We're going to clamp the rotation of those values in vector 3, but it doesn't support export range directly. In this case, you'll need to use individual float variables for each rotation component. Yeah, now here's the problem. We're going in circles here. But, okay, so this is nice though. It's got a setter at least, or a getter and a setter, so that we don't have to refactor the remaining code. But here's the problem. Export subgroup. Oh, that's probably that's the solution, isn't it? Okay. Nice. Okay, let's see what happened now. I don't know how to be consistent with the user interface here. It would just be so nice to have these in line. Huh. Well, let's try this. Take a screenshot. To match the node 3D transforms clean single row design, we need to remove the subgroup and keep it just vector 3 property. There's actually a specialized export hint for rotation specifically. Really? Let's make that 0, but okay. Whoa, interesting, different error. I think we just went back into closer. I need to correct my approach. I'm gonna try simpler export without any special hints. Well, what happens when we do that? I see now that I was overcomplicating it. The built-in vector 3 property should show up with sliders. It does not show up with sliders. I tried. At least we have a group. I think those were the kind of only main ideas I had for the UX improvements. Very small change. Kind of interesting. Just trying to take a look at it. It does look like it misses those, interestingly. Kind of clips through one of them. I don't get this. That way you can't quite land on it, interestingly. It looks like you can sneak past it, but not quite on this one. We can put some in there that allow you to sneak past them though. So that's the cool thing. Cool. It's basically working. Okay, so let's commit these changes. Push that. Open a pull request. Cool. Now we have a pull request. And this one is so small, it's so trivial, I will just merge this. So to summarize this segment, we've added a desired transform export group to give our user interface a little bit more polish. And you can collapse that now. Documents the kind of purpose of this section, and then each subvariable has doc strings describing what that property controls. We tried to mimic the node 3D transform section, but could not get this rotation. The appearance here with these clamped sliders, Claude and GPT both were unable to sort of guide me there. So yeah, let's go ahead and merge the pull request and just tweak the values here. Cool. So that was related to a task that's already been completed. So thanks for stopping by this live code hangout. Remember to check out our code on GitHub at github.com/OurLightStudio/Nexus. I hope you're doing well and have a great day.